Hydrolysis of ester gives acid and alcohol. So if I have ester and this is hydrolyzed, it will generate acid plus alcohol. For example, let us say if I have this ester and this is hydrolyzed, we will have acetic acid and methanol. Now hydrolysis can be done in acidic medium as well as in basic medium. So hydrolysis can be done in acidic medium or it can also be done in basic medium. Let us discuss hydrolysis in basic medium. Hydrolysis in basic medium of ester is also called saponification. Hydrolysis of ester in basic medium is also called saponification. This is called saponification because soap is generally made by hydrolysis of ester in basic medium. So soap is generally made by basic medium hydrolysis of ester. So let us discuss the mechanism for basic medium hydrolysis. So we have a ester and we have OH minus as base in aqueous medium. First step is nucleophilic addition of OH minus. So we have nucleophilic addition of OH minus ion. So OH minus is acting as a nucleophile. So this will attack on carbonylic carbon and we will have a tetrahedral intermediate. In the next step, we have elimination of alkoxide ion. So in the next step, we have elimination of alkoxide ion. So this O minus pushes OR group and OR group gets expelled from the molecule. So we will have acid plus OR minus, that is acid plus alkoxide ion. In the next step, we have deprotonation of acid and protonation of alkoxide ion. So we have simply acid-base reaction. So acid gets deprotonated. Alkoxide ion is more basic, so it will abstract a proton from acid, and we will have ion of acid and alcohol. If we add aqueous mineral acid, carboxylate anion can be protonated. So next step we have protonation. So we have carboxylate anion, and if we add mineral acid, it can be protonated. So finally we will have acid and alcohol. So in this case we need acidification also. If we does not do acidification, that is protonation, finally we will have salt of carboxylate anion. So this is hydrolysis of ester in basic medium. You see, in this reaction OH minus is not acting as a catalyst. Once this OH minus is used, in none of the steps of this reaction OH minus is regenerated. So OH minus is not a catalyst. So in this reaction OH minus is not a catalyst. And that's why this reaction is called base promoted, not base catalyzed. So we cannot call this reaction as base catalyzed. We call this reaction as base promoted because base is used. And this is because in this reaction base is used. Now let us say, if I ask what will be the product in this reaction. So first step we have NaOH in aqueous medium, and the second step we have mineral acid. So what will be the product in this reaction? This is hydrolysis, so we have to break this bond and we will have acid plus alcohol. Now let us say if I have this problem, and if this is treated with NaOH in aqueous medium, and the next step we have acidification, what will be the product? Once again we have to break this bond, so we have to break C double bond O and oxygen bond, so carbon oxygen bond. So this bond, this is carbon and this is oxygen, so we have to break this bond. So we will have this product. So we said in this lecture about base catalyzed hydrolysis of ester. Base catalyzed hydrolysis of ester gives acid and alcohol. The first step is attack of OH minus. In the next step, expulsion of alkoxide group, and finally we have protonation of acid, salt or acid anion to give acid.